This sheet today, you're going to label it number 1. It's called Introduction to Forces and Friction Notes. And in today's note sheet, we're going to learn about forces, what they do, what they mean, the different types of forces, and then we'll talk about friction near the end. So, what is a force? A force is a push or pull that changes the motion of an object. So in other words, it causes acceleration. So forces can do 4 things. They can start things moving, they can stop things moving, they can change the speed and or direction of motion. So this is acceleration. Or it can give energy to an object. So what is our unit for force? Well, forces are given in units of newtons, like Isaac Newton, thus Newton's laws. And it's abbreviated with a capital N, not a lowercase n, capital. 1 newton is equal to 1 kilogram times meters per second squared. This is going to be important and will make more sense when we study Newton's second law. There are 3 types of forces. The first are balance forces. And balance forces are forces that are equal in size and opposite in direction. These do not cause a change in motion. So, to kind of get a visual, we're going to have an object. We're going to see a lot of boxes in this unit. And in one direction, there's 5 newtons of force. In the opposite direction, there's also 5 newtons of force. So these are equal and opposite in direction. So for this one, this is either going to keep moving at the same rate. Object in motion is going to stay in motion. Or it's going to stay still. Object at rest is going to stay at rest. The second type of force we're going to talk about are unbalanced. And this is where one force is bigger than the other. And these always cause a change in motion. So we're going to have our box again. And in one direction, we're going to have 10 newtons of force pulling on it. And in the opposite, we'll have 5 newtons of force. Well, because the force is bigger on the right-hand side, that means there's going to be motion going to the right. The third type of force is going to be called net force. And net force is the sum of the forces acting on an object that cause acceleration or a change in motion. Because remember, acceleration is a change in the motion of an object. So we're going to take the thing from unbalance, our object, our box, and we're going to have 10 newtons pulling to the right and 5 newtons pulling to the left. Now, when we solve for net force, we're going to take our bigger force, called F1, so 10 newtons is bigger than 5 newtons, this is our F1. We're going to subtract our second force, our F2, and our smaller force is always going to be F2. So our net force is going to be 10 newtons, that's going to the right, minus 5 newtons going to the left. So it'll equal 5 newtons going to the right. The direction is really important when we talk about net force. Now, what is friction? Friction is a force that opposes motion. And there are 4 types of friction. There's static friction, which is friction acting on a non-moving object. So right now, if you're sitting in your chair, there's static friction acting between you and the chair. There's sliding friction, which is friction that occurs when 2 objects slide or move against each other. So your pencil or pen across paper, there's sliding friction occurring there. The third is rolling friction. And that's friction that occurs when an object rolls over another. So for example, car tires on the road is rolling friction. And the fourth is fluid friction. And that's friction that occurs when an object moves through air or water. Now, fluid friction is better known as air resistance or water resistance, but it's a type of friction. So if we need to make friction into a force, it's the force that opposes motion. So if our motion, for example, is going to the right up here, this is going to be our friction because it's opposing the motion, and the motion is going to the right because the force is bigger going to the right. On the back, we're going to learn how to solve unbalanced forces. So the first thing we need to do is define our forces as F1 and F2. So our bigger force is always going to be F1. And when I compare 7 newtons to 5 newtons, 7 is greater than 5. So 7 newtons is going to be my F1, and 5 newtons is going to be my F2. Now net force, I'm going to have force 1 minus force 2, which is equal to 7 newtons going to the right minus 5 newtons going to the left. So my net force is going to be 2 newtons going to the right. For my next problem, I'm going to compare 11 newtons going down and 10 newtons going up. If I'm trying to find net force, I know that my bigger force is going to be F1. So when I compare 10 and 11, I know that 11 is bigger. So 11 newtons going down is going to be my F1, my first force, and 10 newtons is going to be my second force, or F2. So net force is F1 minus F2, which is equal to 11 newtons going down minus 10 newtons going up. So it'll equal 1 newton going down. Like I said, directions are important. So your answer, just as an FYI, is incorrect unless it includes these directions. For the last problem we're going to do together, it's going to be our little lightning bolt. Had a lot of fun with these shapes. So if I compare 16 newtons going to the left and 7 newtons going to the right, 16 is bigger than 7. So 16 newtons to the left is going to be my F1, or my first force, while 7 newtons to the right is going to be my F2, or my second force. So in order to solve for net force, it'll be F1 minus F2, which is equal to 16 newtons to the left minus 7 newtons to the right. 16 minus 7 is 9. My unit is newtons, and my direction is to the left because that's the direction my bigger force was going into. Now I want you to do 4 and 5 on your own. And for tonight, you're going to do some independent practice at home that's going to be due on your block day.